Welcome to practical session by Lok Jagruti Kendra University. In this video, we'll determine partition coefficient of benzoic acid in benzene and water system. Let's have a brief intro about what is partition coefficient. When an excess amount of solute is added to two immiscible liquid phases and the mixture is shaken vigorously, the solute distributes itself between the two phases. Partition coefficient is also called distribution coefficient. Normally, the partition coefficient is just the ratio of concentrations of a solute in two liquids. So, partition coefficient simply K is equal to concentration of solute in organic phase divided by concentration of solute in aqueous phase. So, it can be calculated by using this equation where K is equal to C organic divided by C aqueous. But here's the twist. We are talking about how benzoic acid distributes between the two immiscible solvents, water and benzene. In water, benzoic acid stays as single molecules when it is dissolved in it. But when benzoic acid is dissolved in benzene, benzoic acid molecules pair up to form dimers. That's why we take the square root of the benzene concentration to get the equivalent of monomeric units. So when we calculate the partition coefficient of benzoic acid, we use this formula where K is equal to under root C organic divided by C aqueous. The aim of this practical is to determine partition coefficient of benzoic acid in benzene and water. Here are the requirements for this practical. We will use benzoic acid as solvent. We will use water and benzene as two immiscible solvents. We will use 0.1 normal sodium hydroxide, 0.01 normal sodium hydroxide, and phenolphthalein as an indicator. We will use glasswares like separating funnels, reagent bottles, or stoppered flasks, beakers, burettes, pipette, and conical flask. Let's have a brief about procedure before performing our practical. We will prepare approximately 100 ml of saturated solution of benzoic acid in benzene. We will use this solution as stock solution. We will prepare following mixtures according to this table in 4 separate reagent bottles and label these bottles as A, B, C, and D. We can use reagent bottles or stoppered flasks to mix these solutions. In bottle A, we will take 40 ml of stock solution, 50 ml of distilled water, and 10 ml of benzene. Similarly, in bottle B, we will take 30 ml of stock solution, 50 ml of distilled water, and 20 ml of benzene. Similarly, we will prepare mixtures C and D in reagent bottles C and D. We will place stoppers on each bottle and shake them for 30 minutes. Then we will transfer these mixtures in separating funnels labeled as A, B, C, and D and allow these separating funnels to stand for 10 minutes. It will allow the separation of layers. Then after separating the layers, we will collect the both aqueous and organic layer in different dry beakers. We will titrate 10 ml of aqueous layer with 0.01 normal sodium hydroxide and we will use phenolphthalein as an indicator. We will titrate 10 ml of organic layer which we have collected from separating funnel using 0.1 normal sodium hydroxide and we will use phenolphthalein as an indicator. We will note the period readings as V aqueous and V organic for them in this observation table. Similarly, we will perform for bottle C, B, C, and D, and we will note the period readings as V organic and V aqueous. Now we will perform the practical.
Hello everyone, welcome to this educational video presented by Lok Jagruti Kendra University. We are the students at LJK University. Today we'll be performing a very interesting and important physical pharmacy experiment, determination of partition coefficient of benzoic acid between water and benzene. Before we begin, let us take a look on the chemicals and the apparatus we will be using today. We have benzoic acid, benzene, phenolphthalein as indicator, measuring cylinder, funnel, beaker, separating funnel, Distilled water 0.01 normal NaOH, zero point 0.1 normal NaOH, conical flask, iodine flask, and burette. Now we'll prepare a stock solution of benzoic acid in benzene. Here we are taking 100 ml of benzene. Now we'll add benzene in a iodine flask and add small quantities of benzoic acid until saturated solution is achieved. We will keep adding the benzoic acid until saturated solution is achieved.
Now we will take four iodine flasks and label them as A, B, C, D and mix the benzene, distilled water and stock solution according to ratio mentioned in procedure. Now we will add 50 ml of distilled water. Then we add 40 ml of stock solution. Then after 10 ml of benzene in iodine flask A. Clog it and shake it for 30 minutes. Now we will prepare iodine flask B, C and D according to the ratio mentioned in procedure and shake it for 30 minutes. Similarly, we have prepared these C-D mixtures. We use the iodine flask because it has stopper, which reduce the rate of evaporation of solvent. We will transfer these mixtures into the separating funnel and keep it till 10 minutes for layer separation of organic and aqueous phase.
Now we will transfer the mixture into respective separating funnel. Similarly, we will transfer the mixture C and D into respective separating funnels. Now we will put the stoppers on the funnel and keep it intact for 10 minutes so that we get a separated layer of aqueous and organic solution. Now we will separate the layer. The lower layer is the aqueous layer. Now we will collect the organic layer into another beaker. Now we will take 10 ml of aqueous phase and transfer it into a conical flask. Now we'll add 2 to 3 drops of phenolphthalein as an indicator. We will fill the burette with 0.01 normal NaOH. Now we'll titrate the aqueous phase against 0.01 normal NaOH. Okay. Note the burette reading when the light pink color appears. Similarly, we'll titrate the organic layer against zero point 0.1 normal NaOH. Now note the burette reading for organic layer as well. Similarly, we'll titrate the organic and aqueous layer for BCD separating panels.
After performing the practical, we have found the burette readings for organic layer and aqueous layer for bottles A, B, C, and D. We will write those burette readings in this observation table. Based on these burette readings, we will calculate the normality of organic layer and aqueous layer for all of these bottles. And from normality, we will find out concentration, and from that, we will use that concentration to calculate the partition coefficient of benzoic acid in benzene water system. First, we will calculate the normality of organic layer. To calculate the normality of organic layer, we will simply use the equation N1V1 is equal to N2V2. We used 0.1 normal NaOH, so we'll write down 0.1 here, we'll write down burette reading here to calculate the normality. So simply normality of organic layer is equal to 0.1 into burette reading divided by 10. And to find out concentration of organic layer, we will simply multiply this normality with molecular weight of benzoic acid, which is 122 gram per mole. Here we have calculated normality for bottle A solution or bottle A mixture, which is mentioned here in the table. Now we will calculate the normality of aqueous layer and concentration of aqueous layer. For that we will use the similar equation again, which is N1V1 is equal to N2V2. We used 0.01 normal NaOH to titrate the aqueous layer. We will write down the burette reading here and find out the normality of aqueous layer. To find out normality, we can simply use this equation 0.01 into burette reading divided by 10. We'll find out the concentration of aqueous layer similarly as organic layer simply by multiplying the normality with molecular weight of benzoic acid, which is 122. We have calculated the same for bottle A. We have calculated normality of aqueous layer and concentration of aqueous layer, and we'll write these values in the observation table. And from these values, we will use this equation to calculate the partition coefficient of benzoic acid in benzene water system, which was found to be 2.14 for bottle A. Similarly, we will calculate the normality and concentration of aqueous as well as organic layers for bottle B, C, and D, and we will calculate the partition coefficient. We will calculate the average partition coefficient using these four values of bottle A, B, C, and D. Partition coefficient of benzoic acid in benzene and water system was found to be 2.34.